for my late. I was also engaged in something else, but I think I mixed up with the time. All right, so for today, we are going to talk about telling the stories with numbers, smart ways to summarize data. And basically, we are going to talk about how do we summarize data. You may have your objectives clearly stated, but the principal thing is that it is you who is telling the story. And how do you tell the story that your followers will follow? That's what we are going to do today. And if you do have time, we're going to talk about the second aspect, which is inferential statistics. Good. So how do we summarize data? Basically, we have three ways of summarizing any data at all that we do get from our study. We do have the tables, the graphs, and then the summary measures. Which one to use at any particular time will depend on your type of study, on the type of variables you have collected from the field, and of course, your audience. For example, when it comes to academics, maybe a thesis, a dissertation, then we are talking about both the content we are talking about both content and volume. Please hold on for a minute. So basically, when it comes to the academics, maybe you are presenting a thesis or a dissertation, it is both the content and volume. An MSc and MPhil. When it comes to presenting data as part of a manuscript, then it's about content. Because with manuscripts, they just want the minimum number of tables possible. So every situation has got to do with what you need to present. It's for you, the researcher, who needs to determine which one is appropriate and best for that situation. So we are going to talk about the tables, the different types of tables we can present, and how smart can we present the tables. That you can present a lot of data in a minimum number of tables. Then graphs. Graphs. What are the various types of graphs we do have? And then the summary measures and when to use them. What are their importance? So based on this, we are talking about how effective can we design tables and how can we prepare. We'll talk about consistency in data presentation. When we talk about tables, we are talking about frequency distributions. We can have distribution of attributes by a factor, or what we call relational tables. Others will call that as cross tabulation or contingency tables. Then we have what we call the composite tables. When it comes to the graphical way of presenting data, we have the bar charts and the histograms. They look bar and the scatter diagrams, and of course, the spot maps. In terms of the numerical methods, in a set of data, there are two things we look out for. To what extent are the data points aggregating to a center? And that's what we call central tendency. To what extent are they aggregating to a particular center? At the same time, we also want to look at their spread. To what extent are they so far away from each other? So these are the two things which come into mind. So anytime you see standard deviation, then you are looking at to what extent are they far away from each other. And when you see something like mean, to what extent are they aggregating to the center? There are other methods like pictures, rates and ratios, and then measures of morbidity, mortality, which are not anything extraordinary, but forms of what we will talk about earlier. Good. Let's talk about tables. A table is constructed from a data set. And basically, what do we intend to show with tables? Just to show the number of observations at different values of a characteristic. When I say different values, I'm referring to the attributes of a characteristic. And why do we show tables? Importantly, we just want to see whether there's any meaningful pattern that exists in the data set, be it qualitative data or quantitative data. We do tables just to see if there are any meaningful pattern. If you are dealing with a qualitative data type, then each category is counted, and the counted numbers are referred to as frequencies. If you are dealing with a qualitative, that is a nominal scale of measurement, then the number of observations is counted. So for example, if you are dealing with sex, then you are talking about counting of male and female. If you are dealing with marital status, then you are talking about counting of number of individuals or study participants who are married, who are single, who are widowed, and who are divorced. Now, in any table that you draw the table, every table should have a title. And the title, first of all, should be written at the top of the table, above the table. The title should be above the table. And the title should be comprehensive enough such that if anyone picks that table alone and looks at it without reading the text for that table, will to understand the content of that table. If you are not the source of any table you present, make sure that you indicate the source at the bottom of the table, usually in italics, so that you avoid the issue of plagiarism. Each table that you present, and of course, figures and other things, should be self-explanatory. It should be self-explanatory. I should be able to look at a table and know exactly what it means. I don't need to go to a second table before I'll get the explanation of the first table I'm looking at. And all tables that we present should be kept as simple as possible. And this is where I'll say that for best results, your tables should be such that they can fit into a page of your thesis. Although this is not a must, it is advisable because remember, we have table column headings, and the moment the table transcends into a second page, you lose those column headings. So if you draw your table very well, they should be able to fit into a page of your thesis. Also because large tables are also difficult to read and interpret. So the first type of table is what we call the frequency table. What does it do? It just shows the number of observations at different attributes of the variable. And it can be used to show both discrete or continuous data. Now, in any table you draw, make sure that if you have the categories, it should be mutually exclusive and mutually exhaustive. Meaning that every member of your study, every study participant, should fit into only one category of a row. And at the same time, every member should have a category to fit in. So, for example, if you are looking at age and you decide to categorize age into maybe babies or whatever it is, into 1 day to 28 days, the next category should not start from 28 days to 60 days. Meaning that a baby who is 28 days, where will it fit in? Is it category 1 or category 2? Now, in the same scenario, the next, if from 1 to 28 days, the second category should not start from 30 days to 60 days. The question is, a baby who is 29 days, where will that baby fit in? And this is what we call the categories must be mutually exclusive and mutually exhaustive. So below, at the bottom of this is an example of a frequency table. You look at the title, it says the level of risk of cardiovascular disease in 311 patients attending a certain community hospital in a region of a country. This is a title which shows you the number of participants, the population the data was taken from, and the characteristic we are interested in. So the moment the level of risk of cardiovascular disease, you look at the table, you know that we are looking at low, moderate, and high. And if the number of participants is 311, that means the sum of these should be able to reach 311. The second type of table is what we call the composite table. The composite table. In this composite table, you are looking at having more than one characteristic in the table as rows in the table. So in the example we have in table 3 here, we are looking at the maternal social demographic characteristics of study participants. So we are looking at the maternal age, the educational level, and then the religion. Okay, so this is a composite table, which is an expansion of the earlier table we looked at. And most of you will be doing composite tables for your dissertation or your thesis. Now, such composite tables are very helpful because it allows you to group clinically similar characteristics together. So we may have table 1, which is looking at the socio-demographic characteristics of study participants. In such cases, you have what are the socio-demographic characteristics? The age, the marital status, the religious affiliation, educational level, and others. So when you group all these socio-demographic characteristics together, it tells a story. The important thing is you want to tell a story. You have gone out there to collect data from the field. You want to tell a story, and the story must flow. Then another thing are the clinical characteristics of study participants. And this will give you the clinical characteristics relevant to the study. You can have the maternal and neonatal characteristics. Then you can have what we call the anthropometric characteristics. The moment anybody sees a table with the title anthropometric characteristics, then what comes into mind are the BMI, the waist to hip ratio, the waist circumference, and other things. Now let's talk about the relational tables. Relational tables. Relational tables are a little beyond the descriptives because you are doing what we call a cross tabulation or what we call a contingency. If the outcome is made up of 2 attributes and then the exposure is also 2, then people will call it a 2x2 contingency table. So you may have the outcome by convention being the column headings. The outcome is the column headings, and the rows are the exposure headings. Let's do a little exercise. Now, if you look at this table, you can see here, it says that we have antenatal visit before delivery and the outcome of the delivery, whether it was a live baby or not. When you do a cross tab, those who attended antenatal visit before delivery is yes. The outcome, yes. You have 35 study participants. Those who attended ANC but didn't get a live delivery, we have 15 of them. Those who didn't attend ANC but had a live delivery, we have 25. And those who also didn't attend ANC and did not get a live delivery, we have 70. Now, there are 2 ways to interpret this data. And it all depends on whether we have what we call the row percentages or the column percentages. Okay, I want someone from the audience to tell me those who attended ANC and had live delivery, they are 35. If you divide 35 by 70, what do we get? Hello?
So I think some people are putting the answers in the chat box.
Okay, okay,
Uh,
okay.
Is it by 60 or 70?
By 60.
Yes.
Yeah.
By 60.
That's 0.583.
0.583.
The Brilla people are here. NSMQ.
All right. So great. So that is a proportion. If you convert that proportion into a percentage, what do you get?
That's 58.3.
All right. Good. Now look at the same 35. If you divide it by 50, what do we get?
.7, that's 70%.
All right. So you see, this same 35 divided by different denominators give us different answers. And this is very important in how you write text for this table. All right. So if you are dealing with row percentages, then we can say that out of the 50 study participants who attended ANC before delivery, 70% of them had live delivery. Is this correct?
Yes, that sounds
Yes,
about
please.
correct. Yes,
Good.
that's correct.
So this is what we call row percentages. Row percentages being that the denominator is from the row sum. Now, in another breath, I can also say out of the 60 babies who were delivered live, 58.3% of their mothers attended ANC. Is that also correct?
Yes, that's also very correct.
Good. So which one is most appropriate in this situation?
Both of them are giving us different information. So depending on
Thank
what
you.
we are looking for, then we'll go for one. Yes.
Thank you very much, Dr. Pong. So it depends on the story you want to tell. So you see, this is what the journalists do a lot. They look at your data and then they twist the story or the data to suit the story they want to tell behind the data. So I will not say column percentages is better than row percentages or vice versa, but it depends on the story you want to tell your audience. Good. The second thing is that in some situations, for example, we are talking about maternal chronic illness. And you have options like diabetes, hypertension, any other chronic illness, maybe about 4 or 5 categories. But they all have the total number of mothers is the same. So the denominator is not changing. But when you do the calculations, the proportion, summing the proportions and invariably the percentages will be more than 100. How many of you have come up to this before? You have been in a situation that when you sum up, you have done your calculations, but when you sum up the proportion or the percentages, it's more than 100%. Anytime you come out with such a thing, please put an asterisk somewhere and indicate at the bottom of your table that percentages may add up to greater than 100 because one participant can have both diabetes and hypertension. This is very, very important. And then your table will become easily understandable. All right. Any question before I move on to the graphs? Any question?
No question in the chat box so far.
Okay. Okay. Now let's move on to the graphical summarization
Oh,
of data.
just a second. Let me find out if everyone can unmute. Maybe the setting. Please make admin. Please make it possible for anyone to unmute, so that it makes the session interactive. Thank you, Doc. Please continue.
Yes. Let's look at the graphical summarization of data. Okay. Someone wants to ask a question. Dr. Mankwa, Docas. All right. Let's continue. Last week, we talked about the different types of data because it is the fundamental of whatever numerical or tabular summary of statistics that you will get to. The type of graph will depend on your type of data. And the reasons why we do graphical summarization is, in most times, they bring out outstanding features of a data for quick appraisal, which may not be obvious if it was in the tabular format. You can easily see trends or patterns if it were to be in a graphical format. Now, just as we said about tables, the title of a graph should be comprehensive enough to tell the full story concerning that particular graph. And by convention, the title of the graph is written below the graph. The reason is that when we are reading a graph, we read it from the bottom to the top. From the bottom to the top. So the title should be at the bottom of the graph. In addition, any graph will have a y-axis and an x-axis. The axis should be well labeled, indicating the unit of observation. So, assuming the x-axis is the height of study participants, make sure that when you write height of study participants, you indicate the unit of observation, if it is centimeters or it is meters. If the graph is showing more of an attribute, more than one attribute, then it is important that you provide a legend. A legend will indicate the different color meanings of the graph. And of course, if you are not the author of that graph, make sure that you indicate the source to avoid the issue of plagiarism. So we have different types of graphs for different scenarios. We have the histogram, the frequency polygon, the line graph, the box plot. This has got to do with the continuous data type. When it comes to the discrete, we can have the pie chart and then the bar diagram. Of course, we have others like the scatter diagram and then the spot diagram. When we talk about histogram, there are tabular frequencies shown as adjacent rectangles with no space between them. There are intervals. The frequency of the observation corresponds to the height of that particular being. In histogram, the y-axis will give the frequency of individuals. And that y-axis is the numeric or continuous, but then grouped into classes. The reason why there's no space between them is that where one class ends is the beginning of the next class. So we don't separate the rectangles because the end of one class is also the beginning of the next class. That's why we use them for numeric or continuous data type. The next one is the line graph. We use line graphs to show a two-dimensional scatter plot. And what we do, we connect the dots by straight lines. So in the figure we do have here, we have the x-axis as the years, which is from the year 2000 to the year 2009. And then on the y-axis is the HIV prevalence. So in the year 2000, the HIV prevalence was estimated to be 2.3, 2.9. So it was increasing. Of course, we could have represented this in a tabular form. But using a graphical form tells the story easier because we can see a certain trend. We can see a trend. And that trend is that the HIV prevalence increased from the year 2000 to the year 2003, then it dropped by the year 2005. This is real data. And we also use it to observe if there have been any intervention along the line. Any intervention along the line. I remember Prof. Adam Tete and I, we did a paper and we put the interventions during the years that were observing the trend. It looks so nice. So if you take a look at this, real data, the year 2000, that was when HIV prevalence started increasing, got to a peak around 2003 and dropped by 2005. So the question is, a policy, as a form of a policy, they will look at it and ask, what really happened between the year 2003 and the year 2005? And the reality is that those of us who remember, there was a lot of social intervention in the media. Those times, media wasn't that prolific like now. We were all watching the GTVs. And who remembers what actually some of the social intervention started around 2000, around 2005 and thereabout? Who remembers it? Hello? Do you remember the media, the social intervention to reduce HIV from around 2000 somewhere?
Know your status, or something about know your status campaign, or something like that.
Good. And there was a popular television series also.
Yes, things we do for love. Yes.
Thank you. Thank you. Things we do for love. And that really showed, you see, if somebody has given you money and you have done this social intervention, this graph can easily tell the person that, look, I'm achieving results. Therefore, I need more funding. You get it. Assuming I've presented this as a table, it's very difficult to see the trend. But with the graphical form, the trend is clear. Good. And you can even draw a median line across the graph that can tell you that there was what? A decrease in the prevalence. And this line graph can even be done for subgroups. And the grouping in this case was based on the age of the study participants. So with this, we can really see which age group was a major contributor to the decrease in the HIV prevalence. And therefore, policies can be targeted at those who were not, who didn't see that major difference. Targeted policy. The next one is the box plot. So the box plot is a descriptive type of data. We are talking about a numerical data type where it talks about the quantiles. So you have a box plot, as you can have on the left side of the screen, where the median is in there. You have a lower quartile and upper quartile. Then the whiskers, the lower extreme, and then you have the outliers. Between the first quartile and the third quartile is what we call the interquartile range. Interquartile range. We can also have the pie chart. We have used this in several of our dailies. And it's normally used to show a percentage composition of a descriptive attribute of a characteristic. So we have like HIV type of HIV, 1 and 2 labels. And at this stage, I will tell you that versatile type of graphs say that even if you draw your graph in Excel and you copy and paste in your Word, because Word and Excel both are Microsoft apps. The moment you change you can edit your graph in Word or in Excel, and it will automatically show up in your Word document if the file paths are maintained. So I do all my graphs in Excel. However, the pie chart is not useful when there are several attributes. There are several attributes, it doesn't become useful. The next one is the bar chart. The bar chart. The bar chart is similar to the histogram, but it is used when you want to show comparison among discrete or categorical data. So you want to compare these categorical data types. So you have what are the client satisfaction survey, and you have lack of directional signs, no information index, it goes on and on. However, with bar chart, because it is categorical type of data and the attributes are nominal, it means that they are separated. They are separated. And it can either be vertical or it can be horizontal, as we do have it in here. The last but not the least, or maybe there's more there, we have what we call the population pyramid. This is very helpful when we are doing population dynamics. All right, so I'll answer the question, Dr. Osekwachi. So, thank you, Dr. Pong. So we have the population pyramid, where basically we want to see the population of a place, categorized between male and female, and at the same time, the age group. So you have,
sorry
yes,
to cut in like this. Please, can you resume the recording? I think the recording was paused.
on my end. Okay.
No, not from your end, from the admin, the administrator. Yes. Thank you. Thank you. Alternator, please proceed. Thank you.
Okay. All right. So the population pyramid, yes, it shows the population dynamics based on age and then based on gender, and it happens to male and female. And this is what we call a population pyramid. And Excel can do this effectively. And of course, I know also SPSS can also do this effectively. What is a scatter diagram or a scatter plot? It's basically you are looking at two variables. One on the horizontal scale and one on the vertical scale. Now, for scatter plot, we are looking at two continuous variables. So, for example, by convention, the variable stated on the y-axis, that is the vertical axis, is always the response or the outcome, or what we call the dependent, whilst the x-axis is the predictor or the independent. So the dependent variable on the y will depend on what? X. So for example, if you draw a scatter plot indicating BMI and heart rate, who can tell me which one is the predictor and which one is the response? Which one is independent and which one is dependent?
BMI is independent and the heart rate is dependent.
Yes, please. So this is correct. This is correct. So you should know your axis before you draw any scatter plot. The next one is spot maps. Spot maps. In some situations, a spot map can tell you a lot of stories. You can have a spot map, as we have on our right here, which shows the geographical distribution of the various regions and the location of the HIV sentinel sites in Ghana. Now, a look at the spot map based on the color coding can tell you whether the HIV prevalence in a particular region is higher than the other. It can even be done electronically such that it may be flashing, indicating that there is an issue there. And we use this for disease surveillance a lot. And also importantly, it was used during the month of December last year. Who can tell me which group of people used it during the month of December last year and what was it for? That's in Ghana.
Hey, Dr. Nete, is that the source down there? National AIDS Commission.
No, control program.
National AIDS Control Program.
So we used the spot map last year, no, December. Do you remember what we used it for? Who remembers what we used it for? It was easier for all of us to see the spot map. And we're looking at different things. Everybody was looking at different things and having his own interpretation. It was done by two groups of professionals. Let me help you. One group of professionals was the
election results.
Election results. Thank you.
Election results.
Thank you. They used the energy. Looking at it, we could easily see regions that they have counted all the ballots and regions which are left. Imagine we have used table. Would that have been appropriate? So the spot map was more appropriate in this situation. A single diagram showing everything. And they use that a lot in the US during their polls where they show the states which are usually green or no, blue and what? Red. The Democrats versus the Republicans. There is another group of people who used it during the election. Who can tell us? For a certain important reason, national reason. During the same election.
Was
Who can
it
assist? Who can? We didn't hear you.
Cordeo, was it when Cordeo used it to identify the hotspots?
The hotspot. Thank you. That's the word I was looking for. The hotspots.
Hello?
The areas that it was flashpoints
Hello?
for security reasons. Thank you, Zachariah. So the police and the security agencies use the spot maps because they can easily map up a constituency and know which polling stations they are usually trouble. And this, the IGP can say, send 5% of our police force there, permanent. This particular region is not a hotspot. Just take 2% of our population there. So with this, the IGP or the commander in charge of the elections can easily distribute his people without tables, without having a lot of tables. This can easily tell you which place is becoming hotspot. And then you can assign security people there to bring order to those things. And of course, a picture sometimes tells the story more forcefully. At this stage, my advice to my students is that if you go out there to collect data from the public, and you do have the opportunity, with the consent of the study participants, take data in terms of pictures of you doing the work. Because in our part of the world, you don't know when somebody will tell you that you don't even know whether you went and took data or you concocted the data in your room. So if you have the opportunity, with the consent of those who've been in the picture, take pictures of you doing the work. It is very, very important. And when you do your defense, at the end of the slides, you put 2 or 3 pictures of you collecting data. And that one convinces everybody that yes, this fellowship student actually went to the field, collected the data, analyzed the data, and presented the facts on the ground. All right. So, any question before I move to the next session?
Yes, there is one question in the chat box. Let me read it. It says, can you give an example of a pie chart which is not useful?
Okay, so I've seen pie charts with about 20 categories. Each one tiny in there.
That one.
But
I like it. It's very colorful.
It's very colorful, but what is the story you want to tell? The question is, could you have used something else? So anytime you come out with the presentation, the way you summarize your data, think about it. I have in my arsenal a tabular form, a graphical form, and a numerical summary. You decide which best fits the situation. And which best fits the situation will depend on the type of data and the message you want to convey. And importantly, your audience. If you are making a presentation to a minister, you don't want to just show him figures, you want to show him graphs. Graphs. You just want to show graphical form of your data, not tables where the minister will have to see whether there's a difference between this and no. So identify your audience and then pick the most appropriate summary measure to give you the best presentation. Thank you. Any question before I move to the next one? Okay.
Yes. Please note that you can simply unmute and then ask your question. You can unmute. Okay. Dr. Nete, no question in the chat box so far.
Okay, so let's look at the numerical methods of summarizing data. Basically, we have the measures of location, the measures of central tendency, and then the measures of spread. So anytime you see tertiles, then we are looking at measures of location. Percentiles, we are looking at measures of location. When you see anything like median, mode, mean, whether arithmetic or geometric, then you are looking at central tendency. To what extent are they aggregating at the center? Then what is the spread? How widespread are the data points? Then you are looking at the range, the variance, the standard deviation, the standard error of the mean, the coefficient of variation. If you want to compare two unidentical variables to see whether the variation in one variable is higher than the variation in the other. Now, all of these will depend on the type of data. For example, non-numerical data type, like the nominal ones like religion, sex, the tribe, marital status, are summarized by proportion. And a form of proportion is what we call percentage. A proportion multiplied by 100 will give you a percentage. In some situation, a percentage may not be appropriate because the proportion is so small. For example, if you take the medication leaflets of drugs and you look at serious adverse events, if they were to put in as a percentage, it would be 0.0000 something. So what do? They say 2 per 1 million participants. It's a form of proportion, but not a percentage. Now, proportion and percentages have no units. So we are going to look at the various numerical methods of summarizing data. When we say something is a percentage or percentile, it simply means that we have divided the group into 100. So we say the 20th percentile, it is the value or score below which 20% of the observation can be found. So the 20th percentile mark, if they do an exam and the 20th percentile mark is maybe 40%, it means that 20% of the candidates got below 40% or 40 over 100. If we are looking at the 25th percentile, that means we have 25% of 100 means is 25, meaning that we have done the first quarter. It's a quarter of the population. So the 25th percentile is also known as the first quarter, Q1. And of course, the median or the second quarter. And the 75th percentile is also known as the third quarter. The difference between quarter 3 and quarter 1 is what we refer to as the interquarter range. Percentiles and quarters are specific types of what we call quantiles. And quantiles means that you divided something into an equal size interval. If that particular quantile is a percentile, you divided it into what? 100. If, however, it is a decile, we have divided it into 10. If it is a quintile, you have divided it into 5. And if it is a quartile, you have divided it into 4. That is why we say the quarters refers to the first quarter, the second quarter, the third, and then the fourth. And if it is tertile, means you have divided the population into 3. We use tertiles most at times if there are no recognized categorization of a numerical type of, a continuous type of data, like maybe the income level, then we can use the tertile. Another way of summarizing data is what we call the statistical averages. And this refers to the central tendency. The statistical averages. It gives a picture of the central value we are dealing with. And there are 3 commonly used ones: the mean, the median, and the mode. The mean is simply sum up all the numbers and divide by the number of participants. In this case, the mean takes into recognition every member of the data set, because every member is part of the numerator. And we sum them up and divide by the number of participants. It is very easy to calculate the mean because it uses every value in the distribution. The number of every participant is takes part in the calculation of the mean. And it is also very useful for further analysis. However, when there are outliers in the distribution, you should be careful with your interpretation of the central tendency if you are using the mean. For example, You are teaching in a class of university students, young university students, or medical school. So you have the class range, ages between maybe 20 years to around maybe 25 years. Then the dean comes to sit at the back of the class. And a naive researcher is asked to calculate the mean. Instead of dealing with the outlier, it takes the age of the dean in addition to the ages of the students. What do you think will happen to the mean age that naive researcher will calculate? Will it be higher or lower than the actual mean age of the class?
Yeah, it'll be higher. It'll be
It will
higher.
be higher.
Very high. Yeah.
Yes. And that is why it is important that when you take your data, you do what we call data cleaning before you do any analysis. Descriptive data in Stata, we call it code book, to tell you the maximum and the minimum value for all the variables, the characteristics you have there. And look at it, observe it. For all you may know, you were entering data, and instead of entering a value like 25 for the age of a person, you entered 52. That can change your data set. And what is very painful is that for you to finish all this, about to present, and then you are called and told that, check your data set well, realize that there was an outlier. You check and realize that that was not the correct entry. In some cases, the mean may also look ridiculous. For example, we are talking about parity of a woman. Parity of a woman. If you calculate the parity of a woman and it is 4.5, what does it mean? The mean number of children born by a woman is 4.5 or 4.3. And in reality, you can't have a mean of 4.5 women who have given birth, 4.5 children. You can have a 0.5 of a child. So look at the context you are dealing with before you calculate the central tendency. You may have others like the geometric mean, which is used for skew data, like the microbacterial counts or antibody counts. You have to use the geometric mean. The next one is the median. The median. The median is used when the data is skewed. And what do? We arrange all the observations in ascending or descending order, and we locate the midpoint. We locate the midpoint. Now, the main advantage of the median is that even if there's an outlier, it will not affect to a large extent the position of the median. That is, the median is not affected by extreme values or outliers. So it is the most appropriate measure of central location in a skewed distribution. However, the advantage of the median is that we don't usually use it for further statistical processing. But sometimes you can use it for in the non-parametric world. But most times we don't usually use it for further statistical processing. The next one is the mode. It's easy to find, and the mode is, we are talking about the most frequently occurring observation. That is the mode. For example, if you are looking at the type of cars driven by people, the most appropriate measure is the mode. You cannot calculate the median car, the mean car, but the mode, which is the most frequently occurring type of car. And to be biased in my sense, I would say it is Toyota. Is that correct?
Yes.
Toyota is not, all the Hondas are coming these days. Yes. So it is useful for qualitative or categorical data. You cannot calculate the mean marital, what we call it, the mean marital status. You can say majority of the study participants are married. When you say the majority of the study participants are married, what you are referring to is the mode. So this is an example of frequency distribution. And when we say something is symmetrical, it means that the mean, the mode, and the median all coincide in the model if it is normally distributed. However, so
Hello.
yes, let's continue. So when a distribution is negatively skewed, you realize that it is left skewed. For example, if in a class of medical students, one of them comes to the class with a 2-year-old brother, you realize that the data point, or 5 of them come to the class with their younger brothers, the data point will be skewed towards the lower age. And that lower age is what refers to as the tail of the distribution. So if the tail of the distribution is to your left, on the x-axis, the left side of x is going towards the negative aspect. So we call it negatively skewed or left skewed. And where the skewness goes, it pulls the mean towards it. In the same class, if a group of faculty decide to sit in the class while the lecture is going on, and you take their ages in addition to that of the students, those faculty will pull the mean towards them to the right side of the mean because they are older ages, and that becomes positively skewed, or what we call right skewed. In all these situations, the median will always be between the mean and the mode. Good. Now let's talk about dispersion. Now, if you take a look at these data I've given you, if you calculate the mean ages of this data set, each of them gives the same number. Can someone calculate the first data set, and someone calculate the second, and someone calculates the third for me? Any contributor? Sum up the the 7 numbers and divide by 7 for the first and the second.
The first one is 70. Is 60.
And the second,
The second.
The third one is also 60.
good. So when you calculate all the mean, they all of them do have the mean. But take a critical look at the data points. What is the minimum data point in the first set? It's 29.
29.
29.
And the maximum is what? 90. That means
90.
they are
92.
widespread.
92.
92. Thank you.
Yes.
What about the second set?
44 minimum.
Yeah, 44. Then 70.
And the maximum is?
72.
What about the third?
The minimum is 58.
58.
And the
Then
maximum?
61 is the
63.
63.
Which of them? So you see, good. We see all of them do have the same mean. But are the data points, the spread of the data points the same for all of three? No. Therefore, we need to know how widespread the data points away from this mean. And this is what we use. We can use the range, the variance, the standard deviation, which is the square root of the variance, the standard error of the mean, and the coefficient of variation. Coefficient of variation. So, at this point, moderator.
Dr. Nete.
Yes. May I ask the permission that can we stop here?
Okay.
I know, yes. I need to pick my child from the school.
Wow.
I didn't do my calculation well. I thought the class was starting at 7. It missed me up.
Wow.
Yes.
Wow.
So, good. But I promise you, I'll be available for 2 more lectures.
Wow. Thank you.
If you permit.
Thank you. Thank you.
If you permit.
Thank you. That should work.
But is the story coming out fine?
Oh, yes. Yes. Well, let's hear from the other participants. Can we have a few people comment or put in a message, some feedback?
Oh, yes. Yes, please. The story is coming out well.
Oh, wonderful. Yes. I think there's a question in the chat box. Maybe we'll take that one and then... No, I think we can pick this question later. Dr. Nete. Yes. So thank you so much, Doc, for making the time. We know how much we are constrained. And thank you to everyone. Keep the questions coming. We are noting them down and we'll arrange with our chairperson for the research committee for a concluding session on statistics. I believe this has been very, very informative for all of us, taking us to the very basics so that we can make sense of the proposals that we are putting together. All right. So please, you can put your question or you can send your question directly on any of the platforms that we are on or directly to me. We'll put them together. And in the concluding session on statistics, we'll pick it up from there. All right. So thank you so much for making the time. And we also apologize for the initial hiccups. But you've been patient and you've continued till now. So see you at the next session, which will be advertised on the platforms very soon. Thank you and over for now. Bye-bye.
Thank you.